So now we will define another type of set. We have already studied about natural number, integers as well as whole number, and today we will discuss about the fourth type of set, that is known as rational number. Okay, so the rational number is abbreviatory known as Q. So now let us define what is a rational number and how can we identify a rational number. Okay, so before that you have to keep in mind a rational number also known as fraction. As we have enough idea what is a fraction is always written in the form, suppose I am taking an example 5 by 6. It is a fraction and it is written in the form numerator divided by, this is the denominator. Okay, since rational number is nothing but a fraction, then can we say a rational number is a fraction which can be expressed in numerator by denominator form. So let us define it. You can write a rational number, okay, is a fraction which can be defined, or you can say expressed in which form? In numerator by denominator form, or we can say can be expressed in P by Q form. Okay, where P is known as numerator and Q is known as denominator. Okay, so any number which can be expressed in P by Q form are called rational number. Okay, but in order to be a rational number, there are three more conditions that must be followed by any number, okay, to become a rational number. So what are the three conditions? The first condition is condition 1. The first condition is P. P means what? P means the numerator. P must be an integer. Okay, keep in mind P must be an integer. As we know what is integer, okay, we have also idea what is integer. Z is the set of integer. The middle is 0 and towards its right it contains the positive number, okay, and towards its left it contains the negative number. So P, that is the numerator, can be out of Z, any number we can take from this set. Okay, so it must be an integer. Now coming to the second condition, that is condition 2. The condition 2 says that Q is the denominator. Q must be also an integer. Okay, so P also an integer and Q must be an integer. That means Q can be any number out of the set Z. Okay, but comes to the third condition, that is the condition 3, which is the most important condition of a rational number. What is that condition? The condition tells us that Q, that means the denominator, can never be 0. Okay, now in that condition 2 it is told us that Q can be a integer. That means Q can be any number among this number. But the third condition tells us that Q cannot be 0. That means Q can never be 0. Q can be any number from the positive side or from the negative side, but Q can never be a 0. Okay, so these three conditions must be satisfied by any number to become a rational number. Okay, let us verify whether some numbers are rational number or not. Okay, suppose I am taking an example 1, 3 by 5. So I am going to verify whether 3 by 5 is a rational number or not. So first, in order to verify it to be a rational number, it must satisfy the three conditions that we have studied earlier. Okay, so here 3 is the numerator, 5 is the denominator, so it is known as Q. Now you can see P is equal to 3 and 3 is an integer or not? Yes, it is an integer. So condition 1 satisfied, because the condition 1 is p must be an integer and 3 is also an integer. Coming to the condition 2, q is 5 and you know 5 is also an positive integer. So condition 2 also satisfied. Now coming to the condition 3. Condition 3 tells us that q can never be 0, and here q is 5. Is it 5 is equal to 0? No. So we can write q not equal to 0. So third condition also satisfied. Then we can say yes, it is a rational number. Okay. So coming to question number 2 or example 2. In example 2, suppose I have a question 4. Okay. 4 is a which type of number? 4 is a natural number. As we know, it is a natural number. So now we have to define whether 4 can be a rational number or not. Let us define. See, 4 can be written as 4 by 1, because the value of 4 by 1 is also 4. So we can write 4 as 4 by 1. Here p is equal to 4 and q is equal to 1. Okay, let us define or let us verify them. Since p is equal to 4, that means p is an integer. So first condition satisfied. Since q is equal to 1 and 1 is also an integer, so condition 2 also satisfied. In condition 3, in the condition 3 we have to verify whether the whether the denominator, that is the 1, is equal to 0 or not. And we know 1 is not equal to 0, that means we can say q not equal to 0. So condition 3 also satisfied. So hence we can write it is a rational number. So what we have got? We have got, if 4 is a natural number, then it can be a rational number. So we can write any natural number can be also a rational number. Okay. You can write any natural number. Suppose I am writing 7, then 7 can be written as 7 by 1. If I am writing minus 10, sorry, I am taking the example of natural number. So plus 10, so plus 10 can be written as 10 by 1. So any natural number can be written as or can be expressed as a rational number. Clear? Now, let us take one more example. Suppose I am taking minus 7. Okay, so minus 7 is a which type of number? It is an integer. It is not a natural number. And which type of integer it is? It is a negative integer. Now we have to verify whether this negative integer minus 7, okay, will be a rational number or not. So minus 7 can also be written as minus 7 by 1. And here you can see this is the p and this is the q. Now let us verify whether all the three conditions will be satisfied by minus 7 or not. So here p is equal to minus 7. And you know minus 7 is an integer. Yes or no? Yes, it is an integer. So you can write it belongs to z. So first condition satisfied. Okay. Coming to the condition 2. That is q is equal to 1. And 1 is also an integer. So you can write it is also belongs to z. So condition 2 satisfied. Now the third condition is q not equal to 0. And you can see here the denominator part is not 0. So you can write q not equal to 0. As condition 3 also satisfied. That means we can say it is also a rational number. So what is the final conclusion? The final conclusion is that if a number is integer, then it can be a rational number. That means we can say any integer can be a rational number. Okay. Let us take one more example. Suppose I am taking the example of 5 by 0. Now I have to prove whether it is a rational or not. Now here you can see 5 is known as p and 0 is known as q. Okay, so let us define whether all the three conditions will be satisfied by 5f0 or not. Now the first condition is that p is equal to 5, and 5 is an integer, so you can write p belongs to z. So first condition satisfied. Second condition is q. Here q is 0. And you know 0 is also an integer. Okay, it lies at the middle of the set z. Okay. And towards its positive numbers, towards the left it is negative number. So 0 is also an integer. So we can write it belongs to z. So second condition also satisfied. Coming to the third condition. In the third condition we have to prove that the denominator must not be 0. But here you see the denominator part is 0. So I am writing q is equal to 0. And this condition is not satisfied by 5 by 0. That is why we can say 5 by 0 is not a rational number. Okay. And you know the value of 5 by 0 is infinite. Okay. Keep in mind this.